So question 4 then from the 2022 mechanics paper, just a wee 3-mark question here on simple harmonic motion. It describes the situation. What does it say? A particle moves with simple harmonic motion. So you can either think of that like something bouncing on a spring, or sometimes the best way to think of it is just think of a circle, a rotating circle with a point on it. And think of its shadow. How does its shadow move back and forth as this rotates around? Anyway, a particle starts from its extreme position, so a bit like that there, and reaches a maximum speed of 6. Now, at that, it would be 0 there, the speed, and it speeds up through the centre, and it slows down again, it stops here. Speeds up through the centre, that shadow goes like that, stops, speeds up, stops. So it's saying, this is the point then, it's the central point where it reached a speed of 6. I'll just put the speed going that way for having come round. That was 6 metres per second. Now, from there to get to there, it's also 6 going that way. From there to there, it says was 4 seconds. So it took 4 seconds to get here, which means that the period, if it's at its extreme, that's when it's 0. At its extreme, the speed's 0. At its extreme, it took 4 seconds to get to the centre. So it's going to take another 4 seconds to the other side, another 4 to get back, and then finally another 4 to get back to where it started. And that's what the period is, to go through a complete cycle. So it's going to be 4 times 4 seconds, which is 16 seconds. Now, it did just say state. So you wouldn't have needed to show that 4 times 4. B, hence or otherwise, so it must be hence, calculate the amplitude of the motion for 2 marks. Now this is where you'll need those equations. You'll find them at the front. You've got the basic one, which is just the sine one with an amplitude, with a phase. But this is the one you'd be wanting here. V squared equals omega squared times a squared minus x squared. Because you're given that, remember, x, the thing is, this 6 metres per second, you know when that happens? That 6 metres per second happens at the centre, when x is 0. So you know the 6 metres per second, you know that that's 0, and omega, of course, comes, the rotational velocity of it, comes from the period. Because if it took 16 seconds to go around, that means its rotational speed must have been it went through the 2 pi radians, that's the complete turn, in 16 seconds. So omega is going to be pi upon 8 radians per second. Is that worth a mark? It is. And now you know everything apart from A, so that's you sorted then. If I just put them down the order I've got. So I've got this 6 squared, of course the direction doesn't matter, equals pi upon 8 squared times, and that's going to be whatever I'm looking for, squared minus 0. Now the squares don't matter, because to get A I just take this across and divide, so I can get A straight away. You could have A squared equals that squared over that squared, but all the squares are going to go. So that's just going to be 6 divided by this, so it'll be divided by the pi and multiplied by the 8. So that just gives you 15.278 and so on. So that must be 15.3 metres. That's quite a big amplitude.